what is the force exerted by it on the curved wall? What is the force exerted by this liquid on the curved walls? So to find that force, the way we did, okay, first of all, let me take radius B, A, and height H. Density of the liquid is rho. So what is the formula for weight?
Rho into volume into G.
Rho into volume. Volume is equal to
1/3
pi
R1 A1 A square plus B square plus AB into H.
by 3.
3.
That is a volume. Sorry, into G. That is a weight. Weight we know. What is the force acting on the bottom? Force acting on the bottom.
Pi R square
Let's
into
call this force something.
H.
Rho
So
G H
actually,
into pi
wait a
R
second. Why I'm doing that? I should rather than doing that, I should I think make a proper free body diagram. Free body diagram on the liquid. From the below, the force on the liquid from the base is, let us say, F on plane area, and then F on vertical force on the curved surface area. So curved surface area CSA and plane area PA. So what is the force in the plane area? That is simple to find out. Force in the plane area is pressure, which is equal to
Rho G H into pi S square.
rho G into H into pi A square. I am not taking P naught into account, as P naught is acting from all sides. I am neglecting that P naught.
Yes, sir.
This only I have to take. Okay. And then force on the curved surface area. Force on the curved surface area in vertical direction, obviously, because in horizontal it will get cancelled out. Horizontal part is getting cancelled out. Vertical only will remain uncancelled. So that is coming out to be equal to unknown. Okay, it is unknown. Then our equation is FPA plus FCSA is equal to weight. So FCSA is equal to weight minus F plane area. And that way we will be getting.
Sir, it is 1/3 pi rho G H into.
Okay, whatever. One more thing, I could take, if I want to take P naught also into account, and let us say I want to use that, and you will see on the options that P naught is also taken into account. Then here also I have to take, in PA also I have to take P naught into account. Then in PA it will become P naught into pi A square. That it will become. But in that case, the free body diagram will be FPA plus FCA is equal to not W, but it is extra more than W, because this from P naught from above also is acting, plus P naught into pi B square. Then we will do that. Means these two terms will come additionally, this and this. So again, what we get, you can see P naught also will be coming there in that case. We can do one thing. We can take P naught first into account, and after that, if we are noticing that there is no P naught being taken, then okay, we will remove it afterwards. Okay. Next, we have, I don't know, have I taken this example or not? If I have not taken before, you tell me. Taken, then also you tell.
Sir, is it a hemisphere you're drawing?
Yes.
Sir, complete. It's a solid hemisphere in a water in liquid.
Completed.
Curve surface, force on the curve surface, yeah, we have done already, right?
Yes, sir, we have done, sir.
Okay, okay.
Yes,
fine,
sir,
fine.
we did.
Okay, right. How to do by integration?
Yes, sir.
Let us do by another method now, by integration. Then I have to take force on this part, on this ring element, which is at an angle theta. Force on the ring element will be, let us say it is already at a depth. Let us say a pressure at the topmost point, I am assuming to be a reference pressure P. That I'm taking to be reference pressure P here. Then here at a depth this much below, what the pressure will become? This is, let us say, y deep. Then here pressure will become P plus rho G y
Do it. Yes, sir.
into area. Area we can find because we know radius is r, and r into d theta. That will be the width of this ring element, and width multiplied by the length, which is what length ring element will have. 2 pi r sine theta is the length into width r d theta, that is the area. Area into pressure. Pressure is P plus rho G y. So this is overall pressure into this part is area element. But again, that is the force acting in. I have to find force only in which direction? I have to find force again in just in vertical direction only. So how to get that vertical component? I think I have to take into cos theta again.
Horizontal will get cancelled, no, sir.
Sir, into
Yes,
cos
because
theta.
whenever we want to add the forces, we have to add vectorially. So if I want to add vectorially, then I have to take one component wise. I have to add component wise. So one component only I have to add, other component will get cancelled out. Okay, but we have to remember that we have to add component wise. This is now finally the force, effective force along y-axis, and that I have to integrate. Net force along y-axis on the curved surface area. That is coming out to be P is constant here, will not create much trouble for us. So I can just take P into the total dA. I am again writing this total as dA only. I am writing P into dA cos theta integral plus rho G into 2 pi r square into y into sine theta cos theta into d theta integral. What is y? Y we can write as r into 1 minus cos theta. Total r minus r cos theta. You understand this y?
Yes, sir.
From center to P r, and from we have to subtract this below part, r cos theta part. What do we get then? We are getting it as first term I will take later on. That's integral 1 and integral 2. Second term only I am focusing on right now. So second term is rho G pi r square into 2 into y. Y is becoming r. One r will come from y, so that will become
Sir,
okay. I am sharing.
Answer.
So Where was it? 2. Okay, fine. This is done. Into 1 r will come from there. It will become r cube
Sir, share. Sir.
into
Sir, screen.
1 minus cos theta. I started again. Screen share.
Yes, sir, it's coming, sir.
Is it
Yes,
not?
sir, it
Are
is
you not
coming,
getting it?
sir.
Coming, sir.
Coming, sir.
So 1 minus cos theta. 1 minus cos theta into I can take 1 cos theta and into sin theta d theta integral limits 0 to pi by 2. I think enough from here we can get, right or not? Do the integration part now. I hope you could do it easily. It is not difficult. We can write sin theta. Wait a second.
Cos theta. We can
We
write
will
sin
write
theta
d
into sin.
cos theta is equal to sin theta into d theta with minus theta into d theta. So if I do that, then I will be writing it as d cos theta with minus sign into just cos theta only, or into cos square theta minus 1, because 1 minus sign is there in this. So that minus I will multiply with 1 minus cos theta. So it will become cos theta minus 1. Then it will become cos square theta minus cos theta. This 0 to pi by 2. 2 rho g pi r cube. What is it now?
Sir, again it was stopped, sir.
Okay, but I think signal is weak here. Let me go to another place. Okay. So now, what do we get? You can see, I think so. It's, can you see or not? Let me check. Yes, you can see. Can you?
It is structure,
Means broadcast their structure.
and now
Now
it
it came,
came.
sir.
So, does it stuck? Okay. So, integrate it now. You do it yourself. I'm not doing it. You do it yourself now. What is the answer?
So,
1/3 rho g pi r
Delta.
cube, sir. Sir, 1/3 rho
1 by 3.
pi r rho g pi r cube. Yeah,
That's it.
same, sir.
Integration is giving us just 1 only.
Yes, sir. Cos square theta.
1 by 3
cos-
it is giving. Okay. 1 by 3 minus cos square theta by 2. Cos square theta by 2 will give us cos cube theta by 3 and cos cube theta. Okay. Cos cube theta by 3 minus cos square theta by 2 limits 0 to pi by 2. Pi by 2 will give us 0. And 1 by 2 minus 1 by 3. 1 by 6. 1 by, yes, right only, correct. That only we are getting. This is only second term. What about the first term? First term is P into dA cos theta. Can you get the first term also? Please get the first term and tell me what is the answer for the first term.
P pi r square.
You are exactly right. First term will be P into pi r square. First term is P into pi r square. I could have got the first term orally. How will I do it orally? I have discussed such methods before also. Let me discuss it again. Let us say I have a any surface area, not necessarily hemispherical. It could be any surface area. If this is the area dA, and I want to find out the pressure on this, it is P into dA. But let us say I want to take its vertical component. If I take its vertical component by writing it this way, P into dA cos theta, then that will be equal to P into
The
dA phi.
projection shadows, sir.
Then dA's projection in vertical. If if area vector's projection is in vertical direction, then area's projection will be in horizontal plane, because we know vector is always, area vector is perpendicular to area. So if area vector's projection is in vertical direction, then area's vectors will be in horizontal direction. So therefore P into dA. Now if I take all the horizontal area, total horizontal area, then I will be getting here as total area is on horizontal direction is pi r square. So directly we could have done in this way. Understood?
Yes, sir.
Directly we could have got it. Next we have next
Cone, sir.
cone. Yes. Which cone? Okay, that top, right. This example, cone, inverted cone.
Yes, sir.
Let me take example of inverted cone, or I could take example of inverted frustum. Then it will automatically, we can get for the cone also, we can get, we can tell how for the frustum we can get for the cone. Make the diagram of frustum.
Just radius will be larger now, sir. Base, that's it.
Instead of
This will,
A,
it will be
zero
okay.
and
Understand?
B.
Means we already did frustum, right? We already did
Yes, sir.
frustum, and in that case, just
Yesterday.
A will become greater than
Good zero.
A will become greater than B, I think, and I think from that only we will get answer. You are right only, because answer we can get by just changing A and B, because but the force will instead of becoming upwards, it will start getting downwards.
Sir, cone also same, no sir. We can put one radius 0.
Let us see once. What is the force on the curved surface area that you are getting? Just tell me that. From that, I will get idea whether it is correct or not.
1/3 rho g
What
pi
was-
h
1/3 rho g pi h
b square plus ab minus 2a square.
b square plus ab minus
2a square. A square.
PA square,
Yes.
sir.
I want to check whether this term will become negative when b becomes
Yes, sir. It will
less
become
than
negative,
a
sir.
or no.
Negative, sir.
There
And
minus
when b is equal to a, when b is equal to a, it should become 0. B square plus b square minus. Yes,
Yes, sir.
yes,
Zero,
correct
sir.
one. So means this is enough. From even if they are giving it, means the other case, we will take this case only, and in this only, when we put b0, then we get the total inverted cone. So it is a good idea. Actually, I did not do it in this way. Normally I used to do separately, but yes, you got it right. that we could do in directly this way only. Okay. And this automatically will start giving us all the answers. But anyway, I would still like to explain, because this is one thing to get the answer mathematically. And yes, it is very good trick also, and we should follow this only probably. But I'm still not satisfied, and I want to discuss that also in detail, that what happens in that, how do we get the upthrust, what happens in that. So let us see this case. This is smaller one, B, lower one is bigger this time. First of all, I will take a total container with vertical walls. I will take a container with vertical walls like this. And in this red colored container, I will fill it up. I will fill it up to the height up to which the water is filled in the frustum. Up to that height only I will fill it up. Then here outside also there will be water in this red. Extra water will be there outside on this cylindrical part. So now you should understand that the force exerted by this red water on the black one, force exerted by this red water on the black will be same as black part on the red part. Imagine this is a single container without any thing in between, means it is, there are no walls. Imagine there are no walls. This is just a single container. This is single container without anything inside. So this, we are just finding out the force acting on the outer boundary, on the outer part, on the inner part. So how to find out the force on the outer part, on the inner part? Let us draw the free body diagram of the outer part. Free body diagram of the outer part will be the weight acting downwards. Weight acting downwards and force by this curved surface area upwards. From here, the force will be horizontal, which will not be contributing to anything. So the W will be just equal to, this W will be equal to force on curved surface area. That's it. That it will be directly. So whatever weight is on this, whatever weight is extra, that only will be contributing to the force. You understand that? Extra,
Yes, sir, understood.
Action, reaction, pace.
So directly extra weight is so easy to find out. We can get that extra weight. Let us get it now only. In fact, B, this is A. We know the volume of the frustum. So volume of cylinder minus volume of frustum. Volumes of cylinder minus volume of frustum. That will be the force on the curved surface area. Simple.
Okay, sir, we'll do so.
Okay, you can get it, and you can verify that whether it is coming out to be same. And this your method is also very nice. Means just that frustum only we can keep on changing the radius,
Yes,
and
sir.
by that we will
Yes,
get
sir,
answer
by changing radius.
by changing radius. Sometimes they ask this question also, that the inverted cone has mass. They don't give it a mass. They give the mass of the walls of the cone, and they say, they ask this question: up to what height? Up to what height can we fill with a little hole? Tiny hole is there in the top, a very small hole. Why this hole is kept normally in such questions? In order to ensure that the pressure above will be just atmospheric pressure only. Because if it is closed, inverted, then sometimes we
No
may not be able to
atmosphere.
say,
Yes,
we
sir.
may not be able to say it is atmospheric pressure. It may be some other pressure, right? But otherwise, we can guarantee it is atmospheric pressure only. And then we are filling it up to the top. So then we are asking, they are asking this thing, that if the mass of the walls, M is mass of container or the cone, if M is the mass of the cone, and this is just kept on the table, then up to what height we can fill water inside it? Up to what height can we fill water inside it? We may not be able to fill up to the entire height. We may not be able to fill up to capital H. We may be able to fill up to small h only. The reason is because when upthrust will become so much, or the force on the cut surface area, which we call as upthrust also, that will become so much that it will lift the cone and water will start flowing out from the bottom. Because you know, this is this
This
bottom has no
happens,
base. It is baseless cone. The base is not there. It has no base, baseless. So if it is not having any base, then it is just kept on the smooth table only, so that the water normally will not flow out. But when water will lift the cone up, then the water will start flowing out, right? So
Yes,
we
sir.
may then, in that case, what we need to do, we need to just find force on the curved surface area, and we have to balance that equal to the weight. So because that is becoming sufficient enough to just push it up, that we can do. Or we can do in another way, very simple way also. We can make the free body diagram of cone, weight plus the weight of liquid. Means I will say like this. If I have to say, I will do it like this also. Mg for the cone downwards, weight of the water downwards. So Mg plus weight total will be balanced by what force upwards, whatever force is acting from the base, and that is acting equal to here it is P naught, not P naught. P naught we don't consider, sorry, without P, because P naught is acting from all the sides, so that I don't have to consider, because P naught is acting from outside also.
FC
Ignoring
and
P naught,
base area.
Volume
I will
into
just say it is equal to rho GH into area of the base, whatever it is, rho GH into pi
Pi a square
Pi
a
a
square.
plus
That's it. That directly we will be getting. Rho GH into pi a square is equal to mg plus weight. What is unknown in this? Weight is also although unknown, but we can write weight in terms of B and A. That we will write. Mass is given to us. So I think this single equation would be enough to.
Sir, I have a doubt.
Yes.
Why are we not considering FCA, sir?
Why are we not considering what?
Force due to curved surface area.
We could have considered that, but we are making the diagram of the combined system, including the cone. So that is internal force now. The force on the curved surface area by the cone on the water and water on the cone back are equal and opposite, right or not?
Yes, sir.
Yes.
Yes, sir.
So it
Yes,
depends.
sir. Yes, sir.
It depends what free body diagram we are making. Now I am making the FBD not of water. It is not FBD of water. It is FBD of water plus cone. Up to now, I was making diagrams separately of that. You should remember which FBD we are drawing. Otherwise, it will be confusing, no? So you, for example, in this case, when I'm saying FCA, FCSA, and W weight, then here I'm drawing the free body diagram of which part? Let me highlight that part. I'm drawing FBD of this part here.
Most
This-
part, right?
This part here. This part here. This part here. So depends on what part we are drawing the free body diagram for. If I draw the free body diagram of this part, then we understand that FCSA will be acting from on it, and weight will be acting of this body, and from the walls of the cylinder also I'm applying the forces, horizontal forces. But it is another issue that those forces are getting cancelled out, but these horizontal forces are acting from the walls. So means free body diagram should be clear to us always, that for which part we are doing the free body diagram. And also one more thing should be clear, that is it really some cone there, or it is just imaginary? No, it is imaginary because it is a full container I have taken. So I have taken the full container, and in that one part of water is applying the force on the other part of the water only, and there is no wall also in between. And why I'm doing that? To find out the FCSA, because I know the force depends on the depth. If we are at the same depth, then the force will be same, whether it is acting on the solid wall of the container or whether it is acting by one water on the other water, because the pressure is same, area vector is same, small area vector here, then force in this part will be same. And if such parts everywhere are same here as well as here, then the force on these parts and on these parts will be same. So whether you take a solid wall or you take just a this imaginary extended container in which water is applying force on water. Okay,
Yes, sir.
understood?
Okay,
Means
sir.
this was the originally question was this. Originally question was this. Then I extended it and I said that whatever force acts on this, same will be acting on that by water on water. Okay. All right. Next we have we can think of, I think, buoyant force probably. Formally we can start doing buoyant force also.
Sir, hydraulic lift and accelerating fluids, rotating fluids.
Yes, that is also there. Hydraulic lift and accelerating fluids is also there.
Rotating cylinders also there.
This week,
Ac- ac-
today's last day, sir.
Accelerating fluid I have taken already.
Rotating fluid is like remind. Sir.
Rotating fluid I have to take, just rotating fluid I have to take, accelerating I have taken already. Um, Again, I have discussed this kind of question before. I want to do it again. Right. It's a curved semi-cylindrical part. In the wall. Radius of the semi-cylindrical part is R, and above this you assume something maybe R only. And water is filled up to the top, liquid filled up to the top of this. Now find out the force applied on the curved part if density is variable this time. Rho is equal to rho naught into y. Y is the depth. Density increases with the depth as rho naught into y. Can we get this force now on the curved part? And one more thing, in such cases, I forgot to mention that, but it is very special and important case only, and simple case also. What will be the torque acting due to pressure on the curved part about the axis, about this blue line? First, you do this only. Find
0, sir, I think.
exactly right. Torque on
Vertical, horizontal. Passes through axis.
curved part about axis. How will it be 0? Because the forces everywhere are passing through. These are forces due to pressure, and pressure is increasing in this. Therefore, I'm making bigger and bigger vectors as I'm going down. Why? Because with depth, the pressure increases, right? So here, all the forces are passing through center, even if they are not equal. But if they are passing through center, each of these is passing through center, then each contribution of torque towards by each of these is 0. Then it is correct. Then net torque about the axis will be definitely 0 due to the pressure only on the curved part, about the curved part. But if I consider torque on these parts also, then torque about that axis of the cylinder will not be 0. So torque on the curved part about the axis will be 0. Okay.
Yes,
Right.
sir.
Now, second thing is how to find out the force. Forget torque now. Just think about the force. How to find out the force when the density is varying.
Taking a rectangle.
So to find out the force now, I think one possibility is integration. We may have to do this time by writing the force first and then doing the integration. So if you are able to write the expression first, then after that you can continue. You can get the answer also, no problem in that. So how to write the expression? That is what we have to think first. Angle I have to assume first, maybe because this side I can take angle as theta, and this one will be r d theta strip here. What will be the total length of this strip? This strip element, if I am taking small element here. I think area of this part will become, what will be the area of this part?
R d theta into, sir, breadth is B, sir. I mean width.
Width you take b.
R d theta into b.
So dA will become R d theta into b.
B.
But what is dA cos theta and dA sin theta I need? Why? Because vertical force will be dependent on vertical component dA cos theta. dA cos theta will be vertical component dAy, and dA sin theta will be horizontal component dAx to find horizontal force. Pressure will be, here it is 0. I'm assuming a reference to be 0, P not taking 0. Then up to this, it will become rho gr plus r minus r cos theta, right? Extra part here. This part is
Yes.
r minus r cos theta, and above that already it was r. So r plus r minus r cos theta into rho gr. This is the pressure. Pressure into area, I have to take dy to find out the vertical force, and I have to take dax to find out the horizontal force. Now you do the needful integration 0 to pi, because I am taking angle from this line, from this vertical line. From here I can go up to pi angle. Then we can get the forces Fy and Fx. Fx is the horizontal force and Fy is the vertical force. Can you do it once? Please do it. Let us see what answer do we get. And sometimes why we want to get the answer also. Sometimes answer can give us better insight of the what is going on, and we may end up developing some nice trick also. So let us see what do we get after solving it. Can you do it now? I will tell you after that one trick by which we can do it orally. But oral method will not always work. That will work only in this particular case again, because here the rho is varying just linearly with this depth.
Sir,
Yes.
from top up to this curved surface there is r, sir, distance.
Yes, that is R only.
Okay. Sir.
That is R only. Just integration only you have to do, and you have to, what is the problem? Is the integration becoming tough?
No, sir, easy only, sir. We are in the process.
Yeah, why it is?
Sir, will Fy be negative, sir?
No. It can be negative although, for our question which we have done, because we are assuming the force to be in which direction? We are assuming force to be in for our element. See, where we have taken element, for that element the force we have assumed in downward direction. So we are expecting the net answer to be in downward direction. If it is coming out to be negative, it means it is actually upward direction. And yes, it is true. The force should be upwards, because we are seeing here
Because
that this
as
force
given
from the
project
bottom
B.
is more than the force from the top. Force from the bottom is more than the force from the top. So we are expecting answer to be upwards. That is correct only.
Okay, sir.
Okay, here negative does not mean downward. Here negative means upwards. Why negative means upwards? Because the direction of the force on the element means direction of the force on the element is in downward direction, and it will be opposite to that. So definitely it will be upwards. What is it anyway, magnitude wise?
Sir, I am getting rho g pi r square b by 2, sir.
Rho we cannot even get. You are taking rho to be constant. Rho is not even constant.
Yes,
Rho is variable. Rho is equal to rho naught into y. We will get answer in terms of rho naught, not in terms of rho. I think you're not putting rho naught into y. No, wait a
Yes,
second.
sir.
I think no, I understood. You are copying me only what I have done here. But I think I have taken already rho g y, so it is rho naught actually. This is rho naught. Both of these the rows which I have written, those are actually rho naughts.
Sir, squares are r plus r of 1 minus cos theta square will come, so then.
Square will come
OGY.
because
OGY.
yes. Right. Square will come up. Okay, understood. It means no. It means I have taken rho only at that time. Understood now. I had taken rho only, but when I convert it into rho naught, then it will become y squared. Yes, correct. Then you have to do the integration.
సరిపోతున్నాయి.
Fy I'm getting 2 rho naught G pi R cube B, sir.
2 rho naught G pi R cube B.
Yes, sir.
2 rho naught G pi R cube B. I'm getting slightly different, huh? Although I'm doing it orally and I don't know, maybe it is correct or not.
Sir, it is
Although
R
it
cube,
seems-
sir. In fx and fy, both R cube will come.
Into 2R is there, no, sir.
R cube will come, that is true. No, R cube will definitely come. That I know. Okay. I'm not getting R cube. Wait a second, let me check once. Fx will be
First one you
rho
got.
naught into G into 2R. Rho naught into G into 2. What I want to find out? Force. Force is equal to pressure. Pressure is equal. Okay, understood. That I write rho naught into 2R into G into 2R. Yeah, sorry. I should write rho naught into 2R also here. Then it will become 8R cubed. What are you getting for Fx? I think, wait a second, Fx may be wrong, it seems. I think Fx I'm doing wrong, sorry. It is not right. Fx is not right. Fx is not right.
It is coming out to be easy on sir, like 8 by 3 rho naught GR square B.
No, what about Fy?
Fy
I think this one's only we should get whatever I have written here. Are we not getting this? Let me check. Rho naught
why not get
into G into R square into
2 minus cos theta whole square
2 minus cos theta whole square 2 square plus cos square theta minus 4 cos theta into
sir, one more R will
R.
come, sir, B and R
into d theta.
cos theta, sir.
That is
Sir, one more cos theta, sir.
cos theta is
dA
cos
by
theta. Then we are getting 4 cos theta d theta
yeah,
plus
cos
cos cube theta
theta
d
minus
theta minus
4 into integral cos square theta
4 cos square theta
d theta.
d theta. Limits 0 to pi and remaining extra term, this one. That we are getting finally. Cos theta will be sine
Sin theta
minus sine, huh?
No, sir, sin theta only.
Sin only, sine only, sorry, sin only. Sin pi minus sin 0.
Yeah.
Cos cube theta will be one minus sin square theta, I can write, into d sin theta, because d sin theta is cos theta into d theta. See, minus 4 into cos square theta we can write as 1 plus cos 2 theta divided by 2, 0 to pi d theta. What do we get? Finally, sin theta, sin first is 0, sin cube theta by 3, that is again 0. This time also we are getting 0. We are left with last. Minus 4 into 1 by 2 into d theta. Minus 4 by 2 into d theta. D theta is theta only. That is pi minus 0. Minus 4 by 2 into cos 2 theta. Cos 2 theta integration is sin 2 theta by 2, 0 to pi. What is it at last?
Pi by 2, sir.
The term is 0, sir.
2 pi, 2 pi.
Second term.
Second term, I think 0 only. No?
Will be 0, sir.
So, integration of one side.
Sir, we can
Because
write cos cube
first
theta
term is
as
1 into d sin theta.
It will become sin theta, and next is sin
Then
cube theta.
Sin theta. Next is sin cube theta by, so sin cube theta is also sin, because sin is 0 in the lower limit, sin is 0 in the upper limit. But when we are getting function of sin, that will be finally giving us 0 only. Okay.
Yes, sir.
Then what is it? I'm getting minus 2 pi. Is it minus 2 pi or something wrong then?
Sir, minus only,
I
sir.
think
Correct
pi
only.
only. Okay. Correct only. Then we are getting finally answer as multiply the beginning initial term before it. What was that? Rho naught into g into r cube b. So answer is rho naught into g into r cube into b. Finally, this will be answer. Let it be equal to I is this, I is this. I is equal to minus 2 pi. And finally, answer that which we wanted to find out was y. Yes, y. Finally, y is this, which is just telling us that force is not downwards, force is upwards. So you said that only, I think, last time, right?
Yes, sir.
2 pi into rho naught into g r cube. It means I was expecting it to be different, but I was doing some mistake, it seems. What I was expecting this. That also should be there. Wait a second, let me see where I'm committing mistake. I will explain you, and you by explanation you will understand what I was doing. Let's see why I'm not getting answer that way. This is, let's say, hemispherical part. In this part, I'm just finding out if I take the complete cylinder, not hemispherical, sorry, semi-cylindrical. On this, if I take the complete cylinder, then whatever liquid fills this space up, the weight of that liquid will be the upward force. So I wanted to find out its weight. And how I found out the weight? I found out the weight by this way. I thought that density is varying. If I go above and if I go below by equal distances, then above it is that much less as much it is more below, because it is varying linearly. So if I go x distance up, then it is, let us say, in the center, let us say it is something, what you want, rho center, rho c. Then above x distance above, it will be rho c minus some value, whatever that is delta rho. But same, because it is varying linearly, below also it will be rho c plus delta rho. Then if I take the sum of these two, if I take this into some volume dv, same volume, this into dv, and I add this, then what it will be coming out to be? That delta rho term will get cancelled out. It will be rho at the center into dv. So ultimately, I was expecting that answer should be just whatever rho at the center there, multiplied with volume. So easy to determine. What is rho at the center? Rho at the center is rho naught into y. Y means here 2r, r 2r.
3R
Then I
by
was
2.
expecting answer rho naught into, that is rho at the center, multiplied by volume. Volume is equal to pi r square by 2 into d, that is the mass, and mass into g, that is the weight. I was expecting to this. Now why this? Somewhere this is committed around here. Mistake. The thing is, it's very lazy. Let us calculate in fact. What is the rho at the center is equal to not into 2. What is rho? Will be rho naught into 2 minus.
Sir, voice was
What
breaking.
is x?
So voice is breaking, sir.
Voice is breaking.
Voice was breaking. Sir.
Okay. I am saying rho naught into 2r minus x distance above. Rho naught into 2r plus. Rho at the center is rho naught into 2r. Is it okay?
Yes, sir.
Then rho x distance below will be rho naught into 2r plus x. Rho x distance above will be rho naught into 2r minus x. Then volume x distance above and x distance below, the volume will be exactly equal, right or not? Because these are symmetric diagrams. So x distance above, small element if I take, or x distance below, small element if I take, their volumes will be equal. This
Yes,
sky
sir.
blue color volumes. And what will be the total weight of these? Total weight will be, total mass will become rho naught into 2r minus x into dv, whatever that dv is, plus rho naught into 2r plus x into dv. Then what do I get by adding these two? I will be getting rho naught into 2r into dv into 2. That only or not?
Yes, sir.
Means ultimately I'm getting this total volume is also 2 dv. dv this side and dv this side. So total volume is also 2 dv. So ultimately I'm getting rho at the center into dv dash. So I was expecting that only, and that is easy to calculate. Total volume is, integration of total volume will be this pi r square by 2, half of the circle into the width p by. Means I am sure that this answer is correct. There may be mistake in the integration part, because the integration is slightly bigger lengthy. So in lengthy we may have committed mistake, but this is straightforward. There is no chance of committing mistake in this. Answer is straightforward. Rho naught into 2r into pi r square by 2 into b into g. Very much straightforward only. Let us check what we have done in the other case. In fy we are getting as rho naught into g, correct? Rho naught into g, correct. Next, let me do it again once again. What is at depth y? At depth y, formula will be rho naught into y into g into width is coming out to be dy. I think, or I think here there is a mistake here. How you said that it will be squared up? Okay, let me do it again properly. df force here, right? I want to find dfy, theta angle here also. Then I will be getting it as y is what? First of all, y is equal to r plus r into 1 minus cos theta.
It is r
What
plus
is the
r cos theta, sir.
r up to this, and this is
Whatever written is right.
r only, and below this is r cos theta. So this part is r minus r
Okay.
cos theta. Y is equal to r plus r minus r cos theta. Then y into y in rho g into y. Rho g into y is the pressure. Oh, what a stupid thing I'm doing. My God, it's really very, very big mistake. I was applying completely wrong formula from the beginning itself. Such a huge blunder I was doing. Sorry.
Sir,
Formula was wrong. I have used the formula rho naught into G into y square by 2 as pressure. Because we should start from this. dP by dy is equal to rho g. You understood that? Getting it? Say something.
Understood, sir.
yes, sir,
Hmm.
understood.
So that was mistake. I should have taken the formula would have become P naught plus rho naught into G y square by 2. But that otherwise also I'm neglecting. So because so many times I have used this rho naught into Gy and I almost that is applicable only for constant density, uniform density cases. But if it is variable density, then I should start with this only. In fact, in the beginning we were starting with this, but afterwards when we started getting always same, then we forgot the starting formula is not rho g y, but it is P dP by dy equal to rho g. That is our starting formula. From here we get, in fact, this also if I write in a proper way, then it is actually equal to rho g vector dot dr vector. Now dr can be along x-axis, it can be along y-axis, it can be along any other direction also. This is the exact formula which we should write. Okay. Anyway, now using this, what do we get? We are getting pressure into dA, pressure into dy. Sorry, dA will be again, dA will be B into r d theta, right? B into r d theta. This is r d theta here. This is theta. But I again vertical component of this. If I want vertical, then I have to take cos again. And I will be getting P into V r d theta into cos theta. Rho into G by 2 into R into
Sir, again,
again lost.
I think connection is poor, no, sir, there.
Rho naught into G by 2 into. I think today it is becoming very much poor. I don't know what has happened really. Maybe I'm using a different cell today because my cell was not charged fully. So I'm using an alternative, another cell. I think problem is in this cell phone only.
The screen did not come in.
So rho naught into G into. Screen did not come till now.
Yes, sir, not come.
Yes, now it is.
Okay. So I think we are understanding that what was the mistake, and this mistake, because of this mistake, we were getting that extra two factor was wrong there, right? So you know now two methods to do. And yes, because this was a likely mistake to be committed in the exam also, so please put yourself a warning that whenever density is variable, then our starting equation should not be rho g y, but instead of that, our starting equation should be dp by dy is equal to rho g. Put yourself this warning. And other than that, also, you want to solve it, or I think it is now same only, rho naught into g into r by 2 into y square into b into cos theta d theta integral. That is force along y-axis. Now you do the needful. Find it out. You know that last time also we were doing the same thing, except last time we were getting rho naught g into r, I think. This time we are getting divided by 2 also. So same method, same procedure, no difference at all, except one extra factor is coming 1 by 2.
Yes, sir. Here, why
So
we
you can
have to
get the answer now.
Here, why again we need to substitute 2r minus r cos theta, then we'll save.
Why again we have to substitute as 2r minus r cos theta. And then same procedure. Means, in fact, I think I should not have rubbed that last thing, because after that it is exactly same thing only. I rubbed it already. But whatever we have done before, everything was correct, except this starting point. This was a mistake here. Okay, fine. We are getting Fy this way. Two ways we are getting Fy. Second method will be now to find out. Again, this method in which way I found out by that easy way that on an average, the weight is coming out to be weight of the liquid displaced was easy to find out in this. Why? Because effectively weight is coming out by taking just density at the center multiplied by total volume. But that also will not be valid if I give a density which is varying as a function of y, then that method will also not be valid. You can check it why it is not valid in that case.
Yes, sir, it will not be
Linearly
valid.
varied, because if it is linearly varying, then it will not be valid. So now fx will be dfx integral. What is that? That rho naught into g into by 2 into y square into b into r, except cos theta, it will be sin theta d theta. So if you have not done it before, I think last time also you did this calculation, no? Y square sin theta d theta.
4/3 rho naught g br cube, sir. Answer.
What was it coming out to be? 4 by 3 rho naught
G pi r cube into b.
pi r cube into b. That, if I believe you, I don't know it was right or not. Let us at least see the answer. Somebody else, please verify it.
Sir, it is after
Yes.
multiplying only, sir.
Oh, you after multiplying by 2 also, right?
Yes, sir.
Correct. Sorry, this is it finally. So this is our fx. Now let us see. Can we analyze it? Can we find out some deeper reason behind it so that we can do it fast also? Rho naught into g into pi r square into b. Rho naught into pi r square. No, I'm not getting anything like that. I think here we are not getting any such short trick. So we can do it normally, the way we did.
Sir,
By, yes.
write Fy answer, sir.
What are you saying? Fy's answers. Fy's answers will be rho at the center, which is rho naught into 2r into volume. Volume is pi r square by 2 into b into g. That is Fy's answer.
Sir, then by 2 won't, we will not get by 2, sir, then also.
No, by 2 is getting cancelled, no, here.
Sir, okay, sir.
By 2 is getting cancelled. Okay.
Yes, sir.
Fine. So okay, fine. FX also we got. Next we have rotating cylinders. Let us take example of rotating cylinder now.
Hydraulic lift, sir.
Hydraulic lift you have although done, but okay, for formality I'm doing it again. Pascal's law, which we did, that was that thing only actually. If I have a closed container, this is hydraulic lift is also like a closed container. It is a closed vessel. So in closed vessel, the Pascal's law stated that if I increase pressure in one side by certain amount, then that pressure will be the increase in pressure will be transferred throughout the content, throughout the closed volume, without decreasing even slightly. If I increase here pressure by certain amount, F1 by A1, then same pressure will be increased this side also. Then here, let us say how much extra pressure will come here. Here extra pressure coming out will be equal to F1 by A1 only. But if this area is A2, then what force it can apply now? It can apply the force upwards. Yes, so it can apply this force. So the advantage is this now, that by applying force F1, I can get extra force on the other side, which will be equal to F1 into A2 by A1. So by applying a slight force, I can get more force in the other side.
You told us this one by taking a sphere example.
So that's what I am saying. That's what I am saying. I told by taking sphere example, but yes, in hydraulic lift, normally diagram is drawn in this way. So this is hydraulic lift.
So this will be
with the help of hydraulic lift, what we can do? If what this will be
used in car servicing, sir?
This will be used to lift the cars. Yes, this will be used to lift some heavy weights like cars, trucks, something like that. We can lift using by applying less force. We can lift such heavy weight also because the force gets multiplied by what factor? It gets multiplied by factor of what? A2 is greater than A1.
For lifting.
A2 is much greater than A1. Okay.
No, sir. For lifting, they use some device, no, sir. That keeping below the car. For lifting of you.
No, that is different thing. I think you are talking about. I think in which we will be removing tires from the car, something like that. You are asking, right?
Hydraulic lift.
I don't know what device you are thinking about, but
Yes, sir, you were saying that.
This also happens. Means if area becomes large, then corresponding force becomes larger, and we are able to lift it up. Okay. Anyway, next. Next, we have that rotating cylinder.
Yeah, I got it. Thank you so much.
Sir, when the colleges are going to open?
What?
Do you know, sir, when the colleges are going to reopen?
Did they tell you anything about it?
No, sir.
No, sir.
Then I don't know, but somebody is telling that I think not likely to be open any sooner, especially for the entire class. But I heard some news that maybe likely some students, they will call them and they will start teaching them separately, maybe few students. but I'm not sure about it. It is less likely to be in this time, but if some such information will come, it will come from the management side only.
Sir, at
So
that
what about
Dasra
Basically,
Dasra
holidays,
holidays,
sir.
sir? What about
Sir,
Dasra?
Dasra holidays.
The Shara holidays also, they said management can decide only actually such things.
Within
I
2
cannot
days.
decide. So I think the Shara holidays this time they may give a little less, it seems, as compared to normal. Every year they will be giving like 7 days at least, or maybe sometimes 10 days also.
Plan
Then the
of
timetable
holiday
will change, no,
first,
sir, 1 week.
1 week, timetable will change, but right now there is no such information about timetable. But I think for juniors, for you, they are giving, I think, holidays probably. But for seniors, I think they are not giving. Means
But tomorrow only
for
no,
us, if they give
Dasra
enough, sir.
start.
for you they may give.
Enough, sir, it is.
Mhm. For you they may give.
Yes, sir. For us, that is enough.
Sir, yeah.
Why we need about seniors?
Right.
Sir, tomorrow onwards only, no, sir.
Then you can take some rest, no, sir, 1 week.
Tomorrow and
No,
day
I am
after
taking 2
tomorrow
classes of
exams are
seniors.
there in schedule.
Sir, you are
From
taking
Monday there
seniors
is
also,
no
no, sir,
schedule,
classes.
sir.
I am taking 2 classes for
Sir,
seniors.
Monday was
So
no.
Why
for
is, sir,
me,
2
this will not
classes?
be a
That means study hour class you are including.
No. 2
Without study
batches.
hour only, or you
Batch
taking
1
two
and
classes?
batch.
Oh, okay. Batch 1, batch 2.
Without study hour, 2 batches. I'm taking batch 1, batch 2. Earlier I was taking 1 batch only, but I don't know what happened. Now they decided, and from a few weeks I'm taking both.
The juniors,
For juniors, I'm taking only batch 1.
Okay.
So anyway, rotating cylinder. In rotating cylinder, what happens? If I take a small element here, let us say of dm mass, then on this dm element, how the forces will be acting? The force acting due to the rotation will be, if it is rotating with angular velocity omega, dm into omega square x, and downward force is
mg.
dmg.
Yes.
Let this angle be theta. Then I can say dm omega square x into cos theta will be equal to dmg sin theta. Why am I equating these two forces? Reason is, we know that the liquid surface always remains perpendicular to the direction of apparent gravity. So in this direction, the apparent gravity is 0. If apparent gravity is 0 in this direction, then the forces will be balanced in horizontal direction. So here it is like this apparent horizontal is varying from place to place. Why? Because the acceleration is
Horizontal
not
acceleration
constant.
is varying.
Because the acceleration is varying everywhere. So as a result, effective apparent gravity is varying everywhere. And when apparent gravity is varying everywhere, then the surface becomes curved. Something like that is happening here, right? So
Yes.
now, if that is happening, can we find out what is the shape of the curve? We can find it out. How? Dm into omega square. Okay, we can find by this way. Omega square x. Omega square x is equal to, by g is equal to tan theta. Tan theta I can write as dy by dx. Then I can integrate, I think, omega square x by 2 into dx integral will become equal to dy integral. Limits 0 to, let us take this as origin, 0. From here I am taking the distance x, and 0 to y height. Then the relation we are getting as omega square y. Y is equal to omega square x square by 2g. Okay.
Yes, sir.
Yes, sir.
This is equation of parabola. Means the shape of surface will be that of paraboloid of revolution. Paraboloid we call when we rotate the parabola. Paraboloid shape of surface. Surface shape will be paraboloid in nature. It will be paraboloid.
Such example we can see in our daily life, sir.
Yes, this example you can see means you can form the paraboloid by stirring water and then leaving it for some time. Then when it will be on its own, it will be forming that paraboloid, but that paraboloid surface will not be of constant height, or we can say
Yes, sir.
this
After
from here to
completion-
here. This will keep on changing because of the reason that drag force from the friction force is acting, and so it will not happen. But what we are assuming here, for us there will not be any friction force because our cylinder itself is rotating. We are not just rotating the water inside, we are rotating the whole cylinder itself. So when we are rotating the whole cylinder, including the water also, including the liquid also, then the liquid layers will not slip with respect to each other. So the liquid layers will be at rest with respect to each other. So it will be like fluid statics condition only. It is like fluid. What is meaning of fluid static? Fluid static means fluid is at rest with respect to container. Container may move, that is not a problem. But as long as fluid is at rest with respect to container, and as long as the layers of the fluid are not slipping with respect to each other, then that can be considered as fluid statics only. So this is also like that only. So it is like fluid is at rest with respect to different means parts. They are not slipping with respect to each other. One part is at rest with respect to the other part. Okay, and also it is also at rest with respect to the container, because fluid is not slipping with respect to container. So slightly different this situation is as compared to what we experience from in day-to-day life. But yes, it is true that still we can get some idea that this shape is of something like this nature only, paraboloidal nature. Anyway, now this will help you if you know the volume of paraboloid, then that can help you sometimes in such cases. They ask usually such questions of based on this. Do you know what is the volume of paraboloid?
Don't know.
You don't know. Okay, find it out then. Volume of paraboloid you should know.
Yes, sir. By considering ring.
Volume of paraboloid. I taught you long back, but I know you don't remember it now because it was long back in basic mathematics class. I did in this way. If I will say it again, you will remember it. I did in this way. After deriving, first I derived it by integration, but now I'm not deriving by integration. I told you that this paraboloid shape and this shape of cone. I told you that cone has volume 1/3 of the cylinder. Paraboloid has half of the cylinder. Cylinder has pi r square h. Cylinder has what volume?
Pi r square h, sir.
Yeah, correct.
That. This paraboloid volume, this shaded volume is
Half of
pi r square h by 2. H by 2. And this conical volume, this cone within
1
the
by
cone,
3 pi r square h.
within the cone you already know it is pi. Yes. So pi r square h for the solid, pi r square solid cylinder, pi r square h by 2 for the paraboloid, and then pi r square h by 3 for the cone. 1 by 2, 1 by 3. But anyway, we can prove it, and okay, I will prove it again, no problem. But it is not difficult to remember. When you can remember what pi r square h by 3, what is difficulty in remembering paraboloid? I don't understand. We can remember it easily. But we can prove also very easily, so no need to worry that much. Okay. In fact, we can prove orally also if you want. Let me take one paraboloid here. This is inverted paraboloid. And what is the shape? What is the equation of this paraboloid? let's say the downward is y-axis, this is x-axis, this is y-axis, but this is radius r here, and the height is h. Height is h here. At a depth y, if I take a small element, what is the volume of this element here at a depth y? This is x distance. I think first of all, y is equal to k x square in this, right?
Yes,
In
okay.
this kind of parabola shape.
Yes, okay.
We can find that
What is the volume then? Volume will become pi x square into k into dy will be the volume.
Sir, y is equal to minus.
Then I can integrate it, but I will like to.
Y is equal to minus k. So did you include minus in k only?
No, my y-axis is also downwards. No, you see it,
Okay, sir. Okay, sir.
positive downwards. So no need to do that. So we are getting pi x square into k into dy. Now pi x square into k is y, so I can write it as pi into y into dy. We know y into dy is 0 to h total, so it will become pi. Right? I can put h in terms of r. What is h? H is equal to k r square. So what I could write it? Wait a second. I think is it right? Pi x square into, no, k is not appearing here. Pi x square into dy only.
K will not be there, sir.
K will not be there, but then as k is not there, here k will come by k. By k. What is that? If I will put the value of k as h by r square, then I get pi h by 2 into, right, pi h r square by 2. Okay.
Yes, sir.
Fine.
Fine, sir.
Next, here, similar. Okay, why I'm interested in knowing all this? Because sometimes they ask such questions like, let us say this container was filled up to height h, something height, and when what omega we should give so that the water spills out. What should be the omega so that the water starts spilling out? So I think you understand that if this cylindrical height is, let us say, small h, and it was filled up to height, which is this total height of the container I'm taking as capital H. Give me another height name now. Capital H is for this total height. Small h I'm taking as this. What should I do? This one I'm taking as maybe height in the container is h naught. Height of the water in the container was up to h naught height. Okay. Now, understand one thing, that from here, this height, if it rises h by 2 up, then it will be going h by 2 down also. Why so? Why will it be so? Reason is, let us say you don't know that these are going equal up and equal down. You assume it is going x above it and it is coming y below it. Now I will write the volume of the paraboloid. Volume of the paraboloid shape. This empty space volume is, if empty space volume is half of the cylinder volume, then this remaining space volume will also be, half of the cylinder volume. So what is it, this remaining space volume? Pi r square into x plus y by 2. Correct or not?
Yes, sir.
Shaded volume.
Yes, sir. Yes.
Shaded volume.
Yes, sir. Shaded volume is there.
It is the volume of cylinder minus volume of paraboloid. Volume of paraboloid is half, so remaining part will also be half. Now, paraboloid, you understand, paraboloid is within this, that is paraboloid, but it is subtract. If I subtract the cylindrical from cylindrical, the paraboloidal part, then I will be getting the remaining part. That is also half. This is also equal to, this comes from where? This entire volume came from this part, because water was filled up
Yes,
to this.
sir.
Now this water only, in between it created some empty space, and that has risen up. So this volume was equal to what? This volume is equal to just cylindrical volume, which is easy to calculate. That is equal to, that cylindrical volume is equal to pi r square
Into
y.
y.
Now from here we can easily prove
Yes, sir. X is
that
equal
x
to y.
plus y by 2 is equal to y, or y is equal to x. And if y is equal to x plus y is h, then y is also equal to h by 2, because x plus y is equal to h, total h,
Yes, sir.
total height of the paraboloid. So if paraboloid of h height is formed in between, that means the level has gone down h by 2 and it has risen up h by 2. Then it is so simple to tell now how much height this maximum can raise. It can raise maximum height of h minus h naught. That much it can raise or not. Then it will start spilling out.
Yes, sir.
Okay. Water will start. Then how much it can go deep. Deep also it can go by the same amount. Now sometimes they may ask this question, that where it will go, whether the water will spill first or whether the water will touch the base first. What will happen first? So you can tell that this level is close to what? If it is closer to the top, then it will spill first. And if it is closer to the base, then this level will, if the level is closer to the base, then it will reach the base first. It will touch the base first. If it touches the base first, then we have to be careful, because after that it does not remain the complete paraboloid. It does not remain complete paraboloid, and the shape becomes we can say some part of the paraboloid, but not the whole paraboloid itself. Okay. If it touches the base first. But if it touches the surface first without touching the base, maybe like this, then correct, then no problem. Then it remains paraboloid for that much time, for that much duration. Okay.
Sir, time up, sir.
Sir,
Yes.
if h minus h naught is less than h naught,
If h minus h naught is less than h naught, then the
greater
water
than
will
h naught,
start
sir.
spilling out.
Greater than h naught.
If h minus h naught is greater than h naught, then this water will not spill out first, but instead of that, the paraboloid will touch the base. The paraboloid will touch the base, and it will no more remain complete paraboloid. Its shape will become like this. That's what I'm saying. Its shape will become like this. It will reach here. This shape will be. So it is still paraboloid. It is part of paraboloid, but it can obviously not go deep than this.
Yes,
So
sir.
there will be no, here it will be just, we can say we can start seeing the base. There will be not water above it. We will start seeing the base. It will reach to, the water will reach to the sides. Okay.
Yes, sir. Understood.
This part will become visible to us. Okay, then let us end it here.
Upload today's class in YouTube, sir.
Yes, sir.
Okay, I will.